Hey everyone, we're going to look at number 9. I think it's the last one of section 10.4, determine the convergence or divergence by any method. So how would you go through this? Well, again, I give you the uh, series summary, right, sheet, and I would start with the nth term test and work my way down. When I look at this particular series here, 1 over n times the natural log of n to the 1/7 power, clearly the limit as n goes to infinity of the terms we're adding up goes to 0. Of course, that tells us nothing, right? This nth term test, if I can show these terms are not 0, then I know the series is divergent. Well, clearly this is not a geometric series. You can list the first few terms here, and we're not multiplying by a fixed value each time to get the next term in the series. And it's not a p series. Again, it's got 1 over n. If that was it, it would be a p series. But because of this, it's not a p series. And so what's next on our list? Well, there's the integral test. Well, look at this function, right? If we just replace n with the real valued function f of x here, this function is positive, continuous, and decreasing for values of x greater than or equal to 2. And so I can look at the improper integral of this function from 2 to infinity, matching the limits of our summation here. So rewrite that as the limit as t goes to infinity from 2 to t. And by substitution, I'll let u be the natural log of x. Remember, the derivative of natural log of x is 1 over x. So my du is 1 over x dx. So that right there is going to be my du. And u is natural log of x. So I'll have u to the 1 over u to the 1/7 or u to the negative 1/7, which I can find the antiderivative of. I'm going to go ahead and stay in the u world here. So I'm going to change my limits. My limit when x is 2 becomes the natural log of 2, and when x is t, the limit becomes natural log of t. So I'll rewrite it this way now. With the u substitution, I get this. So we said u to the negative 1/7. Remember, add 1 to negative 1/7 gives me 6/7. Divided by 6/7 is the same as multiplying by 7/6. Now I'll plug in the natural log of t and the natural log of 2 here. Just factor out the 7/6. However, as t goes to infinity, the natural log of t raised to a positive power here, 6/7, this is going to go to infinity, right? Natural log of t isn't, the limit as t goes to infinity is infinity. And so that's going to infinity minus some finite value. You could compute this with your calculator, the natural log of 2 raised to the 6/7 power. But the bottom line is this integral diverges, but therefore by the integral test, right, our series diverges. So remember with the integral test, if the series that we're looking at, the corresponding integral, if it's convergent, then our series converges. If the integral is divergent, then our series is divergent. Okay, hope this makes sense on this one. If not, let me know.